Alrighty. Equations of tangent lines. So Jeff has been invited to join the Hangout, so it'd be kind of neat if we can see if that can actually work. It's live broadcasting on the page right now. I don't know. I'm not overly happy with the quality, but it's been pretty good. It's a lot to do, right? To encode stuff. Okay. So these are all kind of the same thing. You know, you're asked to figure out what the slope is, and then you use the slope and a point to determine the equation of a tangent line by solving for the mx plus b thing. Or it might be just sort of the other way around, where you're asked to find out where is a tangent line with a certain slope going to touch the line. So, we'll start out, determine the equation of the tangent line to the curve. Y equals 1 over the square root of x, and x equals 4. And it says put it in both standard and y equals mx plus b form. So we'll see if Jeff's able to make it in with the invitation. So, oh, there he is. Jeff. Hey, how you doing?
I can't hear you right now. Here, let's just see if there we go. Hello?
Hi.
Perfect. Yeah, I can hear you.
Really?
Yep, I just had to change the speaker.
Perfect.
Yeah,
all right.
There. Yep.
Well, that's kind of neat.
Yeah, it's cool. It works.
All right. So we're right in the middle of it. You did the example. Worked out okay?
Yep, I did the lesson last night too, just to go over that.
Oh. So this is going to be extra because I'm just doing the exact the same example.
Just want to make I just want to make sure I've got all the concepts down. So that's good. Yeah.
Perfect. So we're going to start out. We're determining the equation of the tangent line to y equals 1 over the square root of x when x is equal to 4. And so you'll never guess what we've got. Two things we could do. One is we can figure out what the y-coordinate is at that point, because we know we're probably going to be putting it into the y equals mx plus b equation and solving. The second thing we're going to do is we're going to find the value of m. And we're going to find the value of m by taking the derivative. So the y-coordinate is equal to 1 over the square root of 4, and which is 1/2. So there we go. We're actually trying to find the slope of this at 4 and 1/2. And Jeff, if you see me make a mistake, don't hesitate to correct it, okay?
Alrighty.
Okay. I'd ask Lindsay too, but she's too shy. She refuses to. She actually doesn't breathe throughout the entire process. Okay. Now the next thing we're going to do is we're going to turn this into from radical notation. We are going to turn this into power notation. Okay, so that we don't have to do anything fancy. So I've turned y equals 1 over the square root of x into y equals x to the exponent 1 negative 1/2. And I'm going to take the derivative just the way I always take the derivative. I'm going to subtract 1 from the exponent, and the exponent is going to come down into the front here. And this is my derivative for that function. So it's pretty ugly, but we'll work our way through this. Okay. This is the derivative. It's going to tell us the slope everywhere. So we are going to figure out the slope when x is equal to 4. Okay. So 4 to the exponent -3/2, which is, gee, that's kind of complicated, isn't it? So that's 1 over the square root of 4 cubed, -1/2 times 1/8, -1/16. Wow. So sorry, that's the square root of 4 cubed, so that's 2 cubed, so it's 1/8. When I do the product, I get -1/16. Jeff, did I do that right?
It looks like it. Yep. I had a question actually. Could I if I were to express the derivative function, could I just write it as -1 over 2 root x cubed?
Yes, you can.
Is that okay too? Okay, good.
Yeah. So yeah, I'm whatever works for you, as long as I can tell what you're up to. That's all. Yep. In fact, that's probably the correct way to express that derivative.
Okay.
Or, sorry, not correct, but
it'll work either way, but yeah.
It'll work either way. Yep, that's right. Okay, so we have our point, we have an x and y coordinate, and we have a slope. And so we can actually move this into y equals mx plus b so that we get the equation of the tangent line. So y equals mx plus b. The only thing I don't know is b, but I do know y, even though I just got rid of it. What was y? Was it 1/2? So 1/2 is equal to -1/16. And then x is 2, correct?
4.
X is 4, just like I thought it was. Okay. So 1/2 equals -1/16 times 4 plus b. 1/2 equals -1/4 plus b. So 3/4 is b. And so I figured out what my y coordinate is. It's 3/4. And so I figured out what my b value is. And so I can put this into y equals mx plus b because I figured out my slope over here. And plus 3/4. And when I say 3 over 3, I mean 3 over 4. There we go. All right. So it says put this into y equals mx plus b form. It also says put it in standard form. And so to get rid of or turn this into standard form, basically what I need to do is I need to get rid of all these fractions on the bottom. To do that, I'm going to multiply through by 16. So 16y equals -x plus 12. And now I'm going to move everything over on the other side. X plus 16y minus 12 equals 0. So there it is in y equals mx plus b format. Here it is in standard format. The problem solved. So we went from an x coordinate to finding the y coordinate of the point of the tangent to taking the derivative so that we could get the slope. We've turned it into the y equals mx plus b format, and then we went in through and turned it into standard format just because people like that. Jeff pointed out that a more appropriate expression for that, that derivative is 1 over 2 square root of x cubed. Thanks, Jeff.
Yep.
Way to upstage me. Okay, move on to another problem, but they're all going to look pretty much the same. So Jeff, you're getting this with no delay, eh?
No, this is pretty live, I think.
Yeah, this is much better than I thought it would be.
Mm-hmm.
Okay. So it says find the equation. Find the equation of the tangent. tangent 2 equals x squared plus 6x plus 9. It has a slope of 6. In the library. Well, okay, so we're asked to find the equation of the tangent to this particular curve that has a slope of 6. We don't know the x-coordinate. We don't know the y-coordinate. We do know the slope, though. And so without further ado, what we'll do is we'll proceed to the derivative to see if we can figure something out from there. So I prime equals 2x plus 6. So this is going to be my slope right there. So 6 equals 2x plus 6. And now all I have to do is solve for x, which is 0. So I know that when x is 0,
that's how much I did. I see it. It's cool. Yeah.
is that Mr. Ferguson giving you a hard time back there?
Oh, just a couple of my old Chesley teachers coming in.
Bully.
Yeah, they're bullying me. It's all good. Sorry.
Okay, so x is 0. So we've got the slope, we've got the x-coordinate. We do not have the y-coordinate, and we don't know b yet. And so to get the y-coordinate, we're going to put a 0 in here, and I just love putting 0 into stuff where I have to use an x. So y equals 0 squared, y is equal to 9. So the point of tangency is that zero and 9, and that slope is 6. So I'm all ready to go to press here with my y equals mx plus b format, which is, by the way, my favorite format for doing this. So y is 9, slope is 6, x is 0, so b is 9. So that the equation of that tangent is y equals, lost it, 6x plus 9. Okay, so we went to having a slope, to using that slope to finding the x-coordinate, where that slope is. Once we had the x-coordinate, we brought it back, found the y-coordinate from the original equation, and we used those 3 pieces of information to solve for b in the linear equation. Okay, ready for one more? Lindsay is nodding her head yes. Let the record show. Okay. Last example. This is my favorite kind of example because it's super hard to set these up. Notice that they say at what point, and then sneakily put the s in brackets, does the curve y equals negative 1/3 x cubed plus 3 halves x squared have a tangent with the slope of -4. Okay, and so this is a cubic. Potentially there's more than one place where this curve could have a tangent line with a slope of -4. But we are going to do exactly the same thing. We've got the equation, we've got the value of the slope, and so what we're going to need to do instead, we don't have any x-coordinate, we don't have a y-coordinate. We're going to have to go to the derivative right away so that we can figure out our x-coordinate. So y prime equals negative x squared plus 3x. plus absolutely nothing. I know that my slope is -4. And let's see. Let's move everything over onto the left-hand side so that I don't have to deal with a negative x squared. And so now I'm going to be solving for x with this expression right here, x squared minus 3x minus 4. So if I'm really lucky, it's going to factor out. And today I'm really lucky. So this is going to be x minus 4 and x plus 1, both equal 0. And so x equals 4 and x equals 1. Both of those values of x satisfy this quadratic.
-1?
Yeah, I'm pretty sure that's what I said, Jeff. Must be a...
Sorry, yeah, yeah, it's all good. It's just probably the hangout.
Thank you for that.
No worries.
I'm actually lying. Yeah. Okay. So it says at what points does that curve have tangent slope of -4? What we're going to do now is we're going to find the y coordinates just by substituting the x's back in here. Oh my goodness, this is like an x cubed. And so when x equals 4, oh, that's not going to be so bad. 16, 64. And this is 16. 16 times 3 is 48. 24. 24, 64. Oh, 24 times 3 is 72. 72. So this is going to be 8/3. And so at 4 8/3, it's going to do the trick. And now we're going to go through the same process with -1. And so this is 1/3 plus 3 halves. And so y is 2/6 plus 9/6, 11/6. So the second point is -1, as Jeff has pointed out, and 11/6. Hope I got that right. So that's it. Jeff, thanks a lot for tuning in.
Yeah, no, thanks. That was helpful. That was good.
That was really good. I really wanted to test this out with somebody actually live in the show. So that's great. I appreciate that a lot.
Yeah.
Any extra questions?
Just one thing. For the exit quiz, I don't think there's anything in that right now. I tried to do it last night. I just tried to access it. I'm just going to try it again. It says no questions have been added yet.
All right. What I'll do is I'll just delete that.
Oh, okay.
So your job is to make up a question that is really hard and try and answer it.
All right. Sounds good.
All right. Well, it's good to see you again, Jeff.
Yeah. Thanks. Sounds good.
So we'll actually target having a test like next Friday, probably just before the March break.
Yeah, that sounds good.
And it'll tidy up all the, you won't have to worry about anything over March break, basically.
Exactly, yeah.
Yep, we're on track for finishing right on time so far, which is pretty amazing. It's been a good group too.
Yep, sounds good.
Okay, thanks, Jeff.
Alrighty, thanks. Yep, see you later.